welcome back. Let's talk about big data. So basically, what is big data? When we're talking about big data, we are talking about extremely large sets of data or data sets that can be analysed computationally, and that analysis reveals patterns, trends, associations, especially when they relate to human behaviour. The definition that the reading you've been given refers to first goes way back to 2011 to a McKinsey paper, easy to find online if you want to have a look at it. It's quite interesting to explore how our thinking has changed in the years since. But in that paper, McKinsey defined big data as a data set whose size exceeds a database's ability to acquire, store, manage, and analyze data and information. So why does this matter to us? Let me change there. Before I get to why it matters, let's look at some of the other attributes of big data. Going back to, I think 2001 or so, Laney identified 3 V's of growth: volume, variety, and velocity. So volume here is talking about a range of things. The amount of data actually matters. With big data, you have to process high volumes of low density and often unstructured data. The data can be of unknown value, for example, a Twitter data feed or click streams on a web page or a mobile app, or data that's coming from sensor-enabled equipment, an Internet of Things device. For some organizations, this could be terabytes of data, tens of terabytes of data. For others, it could be hundreds of petabytes. The volume of the data is extreme, and hence why we call it, the name on the tin, big data. Velocity here, we're talking about the fast rate at which the data is received, and it can also be the velocity or the speed of acting on that data. Normally, the highest velocity of data streams directly into memory, as opposed to being written to disk, is really where that came from. But internet-enabled smart products, so Internet of Things devices, tend to operate in real time or near real time and require real-time evaluation and action. So that speed is really, really important. And then variety. Variety here refers to the many types of data that are available, some of which is structured, some of which is unstructured. Before big data analytics, we needed to have structured databases in order to make sense of large volumes of database. Traditional data types were initially structured to fit neatly into relational databases, but now with big data, we see many more forms of unstructured data type. Unstructured or semi-structured data types, for example, text, audio, video, music, all require additional pre-processing in order to derive meaning and support the metadata that is ultimately used to make sense of that data. Now, since Laney, as the paper mentioned, there are at least 2 more V's that are widely accepted, value and veracity. So when we're talking about value here, we're talking about the value of the data, both from from the point of view of the end user, but the underlying data as well. It's statistical value, it's event value, it's the use of correlations in order to undertake predictions. And then also, and I suspect most importantly and most worryingly, is this question of veracity. In order to really be useful, the data that is analysed and the results of the analysis needs to have veracity. So here we're talking about is trustworthiness and authenticity, and the origin and reputation and even accountability of the data providers. Let me just put that slide on the screen so you can just take a quick look at it, and those of you who are playing along at home, you might want to have a look at the slide to just think about these things. Now, the data scientists among you will be aware that there are plenty more V's that we could add into this mix or this definition of what we're talking about when it comes to big data. I don't see the need to really dig into it at that level of detail right now. But again, I just want you to be aware that what we're talking about is vast amounts of data. And what's really interesting here is not that there is so much data, but how technology has evolved for the processing and dealing with that data. And understanding that is going to underpin the work that we start to do as we think about the predictive and machine learning qualities of this analytic or algorithmic approach to dealing with data. And basically as we understand more about how AI works, which is where we'll be starting next week. So where do you see big data in action? All over the place. We see it in traffic apps, we see it in music and video and the kind of apps that help us find the things that we want to see. We see it significantly in online shopping, logistics and distribution, but also in the rideshare schemes that we use through to emergency services, the dating apps that you might use. I'm way too scared, let me tell you, in insurance, healthcare, and social media. Big data is becoming ubiquitous, and we often don't even notice when and where we see it. One of my favorite apps to use is Waze. There are other similar versions of it, but essentially how it works is it tracks where you are on a map that you can see on your phone. Now, how does it do that? It's essentially your phone is pinging a satellite at any given time, and it's basically as it pings and it pings the towers, it can see how you're moving. Okay, simple enough. But because it's also pinging many other vehicles and many other users at the same time, when there is sufficient volume of data coming from different individuals, it's able to tell whether the traffic is busier than usual or not. And then using its predictive capabilities based on huge amounts of data of what it's seen happen in the past, it can predict an alternative route, and it can adjust in real time because there's been an accident or there's some roadworks. It uses crowdsourcing effectively to keep updating that data in real time. It's just absolutely useful and fascinating, but that's fine for me. I live in the city. If I'm the only person who's lives in a 200-kilometre radius somewhere in Central Australia, then the data, even though technically it's de-identified, if I'm likely to be the only person in a vehicle travelling from A to B at a particular time of day. So pay attention this week to where you might be interacting with big data and think about what that means for you and for others. Different kinds of uses. They include information management. Think about the number of mobile phone subscriptions there are worldwide. It's used to predict energy demands, traffic I've just mentioned. It helps with healthcare, tax collection for governments. One of the most interesting thing I think that's happening at the moment is the use of big data in what we call RegTech or regulatory technologies, and also SupTech, supervisory technologies. These can be really useful in relation to seeing tracking unusual behavior. When you get an alert from your bank saying that your credit card has been used in an unusual way, that's effectively using big data to recognize conduct or activity that is unusual for you. So RegTech is the ways in which, or actually I'll use SupTech, supervisory tech is a better example. Stock exchanges use SupTech to identify unusual trading patterns when they're looking for insider trading. that big data definition that I started with basically came from that McKinsey paper. So big data is defined as a data set whose size exceeds a database's ability to acquire, store, manage, and analyze data and information. So back in 2011, McKinsey were basically saying, well, in order for a database to make sense in normal circumstances, using 2010 and prior technology, we needed a data set that was of an appropriate size so that the database could actually bring in data, do something with it, store it, manage it, and then analyze it. And so big data or big data analytics is when the data isn't appropriately structured for a traditional database. The image on this screen now, again, comes from a more recent McKinsey report where McKinsey are advising companies. McKinsey is a massive consulting firm, and they're advising companies on how they might be able to use big data, and basically identifying that in order to be able to profitably exploit their own big data capabilities, they need to have this kind of pyramid. It needs to sit on foundations that involve organization and governance, that they need to be able to draw insights from the data and then ultimately turn those insights into action in order to make sure that they are actually appropriately and ethically making profitable use of the big data analytics that they are able to achieve. There are many, many benefits for business and for humanity in being able to use big data analytics. Again, let me show you this slide. I've got a list here. We see them being, big data analytics as being absolutely fundamental to identifying root causes of failure in real time. And this is the kind of analytics that sits behind those IoT devices that are self-diagnosing and self-repairing. Data-driven marketing is absolutely up there as a benefit for those who want to market, and maybe the absolute opposite of that for those that are being marketed to all the time. Fraud detection I've mentioned before, so many new different forms of insight. So the next step here is to take a look at these benefits, to think about whether they are universally benefits or whether there's a quid pro quo, whether there's a balance that we need to do to ensure that we're doing the right thing, and then think about what the legal considerations are for businesses wanting to take advantage of their data or to deploy big data analytics as part of their business processes. And that's what we'll do in the next video. I'll see you then.